Welcome back, dear friends. Something exciting today. I want to show you how to turn a series of blocks and shapes like this into an amazing steampunk invention like this using 3D Builder, which, if you've got the latest version of Windows, is free to install. How fabulous. And the best thing of all is that by creating this on the screen, you're also creating all the data necessary to actually 3D print it. It doesn't get much better than this. So, on with the show. So the first thing to do is to find out the overall dimensions of the item that you're going to design. So here's the original 2D drawing, the sort of sketch that I've done of the steampunk time zone clock. And here is the actual alarm indicator. It's going to have a reflective reflector and some sort of flickering lamp. So I've drawn out the dimensions, and I've created a cube, inserted a cube in 3D Builder with those dimensions, so I know the depth, the width and the height. You can also see there is the model of one of the flickering lamps beside it, so I can actually see how it'll fit and get a better idea of how it's all going to go together. Now with 3D Builder, there's several ways of changing shapes and moving them. You can grab on the little arrows that lurk around the shapes, or you can type in sizes, dimensions and positions in the box at the bottom like I'm doing here. I've decided to start by making the reflector. That's some sort of point to start, some sort of reference. It's a bit daunting otherwise. So I've worked out the diameter I want it, and now I'm using the slicer tool to slice it in half to get the reflector shape. There are other ways of doing this, but the slicer tool is really nice, and it just happened that that's the way I decided to do this one. There is a hollowing tool which I could have used. I'm going to type in the dimensions that I want at the bottom, and then I'm going to overlap it. And one of the lovely things about 3D Builder is the intuitive snapping, like magnetic snapping, as you move things around. It is really good at working out what you want it to do, what you want to line up. I've been amazed because it doesn't have an align function as such, it just has the snapping. If you hold down shift, by the way, and move something like this, it doesn't snap, so you can sort of tweak little designs and move little movements and things. Right, so we've got it lined up. Now the next thing to do is to use the subtract function. Isn't that amazing? So with a click of a switch, it's subtracted the shape that you've selected from whatever it's over. So I've now got a reflector, and I can move the model of the dimension model of the flickering lamp that I'm going to use and just get a better feel of what it could look like, how it could be positioned and aligned. So now I've created a slab to do some sort of back part support, and I'm going to change the colour now. It's got a lovely paint command. Look at that, isn't that amazing? It's turned it into shiny silver because I'm going to spray up the 3D printed part for the reflector. I can finally see what the inside of my computer looks like, some sort of grill or something. So now I'm going to continue working on the support for the reflector. I've used that slab, I've inserted a cylinder and stuck that on the side, well, grouped it on the side. I'm going to use the cylinders to make a hole in to add some support so I can put screws through. I've just duplicated that cylinder and then shrunk it down to 4mm or 4.5mm I think, and again snapping it into the centre because I want to make the hole for the screw. So I'm happy it's all centred. I'm going to use the subtract tool again, and you can see, isn't that amazing? I must stop going on about how amazing it is, but having grown up with huge sheets of tracing paper and a pencil to do engineering drawings on, this is just incredible. When you rotate any object in 3D Builder, it's rotated about its centre, which you don't necessarily want. So what I'm going to do, the trick I've found in lots of different designs, is you produce a duplicate, mirror it, and then you group it with the original. So if you like, you're creating the centre where you actually want the centre, and then when you rotate it rotates where you want. And then after you've got that done, you can then delete the bits you don't want. So I'm using the group command. Once I've lined up both sides, the group command's on the right hand side with the other select and deselect tools. So I'm going to group it and then rotate it like so. I've also done another copy because I want to end up with 2 of these at 45 degrees. So I'm going to select all the different bits again and then rotate the whole lot by 45 degrees, like so. Then once you've rotated it, you can then delete the bits you don't want. All objects have 3 types of settings. They've got the X, Y and Z position in space, they've got their dimensions, the size, and they've got their rotation, which again is just, it's amazing how 3 lots of settings can be so powerful. Perhaps I'm being naive, I don't know. Anyway, it's all very exciting. So there you go. We've got the back bits now, 2 of the supports. At this stage it's becoming less daunting because I've actually got something to look at and work with. When you're just faced with some blocks, it's a little bit daunting. Now I suddenly realised, why have the flickering flame effect vertical? Why not have it horizontal, which is lovely? So many benefits. It means that the reflection in the reflector will be far more symmetrical, and it'll fit more nicely. It'll just be great rather than having it vertical, which was my original idea. Now I need to think about how to connect it up. The other really important part, what's it going to connect to? I've got the overall dimensions correct, and as you saw, I want to have it connected to some 15mm copper pipe. So I'm going to create, rather than using a real plumbing fitting, I'm going to create one of my own. It means that as I've got copper fibre filaments for the 3D printer, I can make it look really realistic, metallic, but it also gives me so much freedom to then add complicated pieces of plumbing to make it look like it, if it was a Victorian invention, it could actually work. So here I'm just measuring, taking dimensions to find out how large this connection needs to be. The very important thing about it is that I need to be able to have it the right size to push or glue in normal 15mm copper pipe by either side. I also need a hole through the middle so that I can poke the wires for the encoder and other bits and pieces. Right, so fiddle around with that for ages and then hollow out bits with the subtract tool. We've ended up with this. Now to get it in the right place, with my limited brain with mathematics, I've just added a cube that's the right diameter, the right distance from the bottom of the reflector to the center of the plumbing. And then I've created another cube at the back that's going to line up with the back of the whole thing, and I can then slide the fitting across, line that up with the center, and it very cunningly snaps into place as always. And then I know that's where it lines up. That's all the measurements I really need to find. I now know it's going to fit within the Steampunk clock, so I don't need those cubes anymore, so I can delete them. As you can see, now I'm thinking about having some sort of disc at the front to hide the flickering lamp, just as was reminiscent of old limelights and things. So I've copied a reflector over, flipped it over, and now I'm going to use another amazing tool, which is, and I can't remember, I can't see it on the screen, basically intersect, I think it is. Isn't that amazing? So where the 2 objects collide, so to speak, overlap, it will then leave you that and take away everything else. So I can bring that, clip that back into the middle. I'm so pleased with that. That looks great. I'm not worrying about the 2 diagonal bits of the back support, the brass bits at the moment. I'm just going to leave them for now and take them out later. I've made it slightly bigger and now I'm going to paint it. So I'm going to select that and then go to paint, and I want that to be the brass, so it goes with the back, because if it was a real Victorian invention, that's what it would have been made from, especially with heat, because they obviously wouldn't have had LEDs or light bulbs. They would have had either gas or limelight or something such as that for illumination. So now I've come to the stage where I need to get rid of these 2 bits. So using the wonderful subtract tool, I can duplicate everything and then create that, cut the fronts off. So let's do that now. So I'm going to select everything I want to copy and clear the decks a little bit. There you are. So that's what we've got at the moment. So select everything and use the duplicate tool to create a copy, which we can then fiddle with. It's also useful if you're going to make changes to your design and you're not sure whether it's going to work, just to do a copy and have it just in reserve, and obviously keep saving everything just in case. So I'm now going to remove all the bits that I'm not interested in, and select the reflector and use the subtract tool. As you can see, perfect. So I've used a saw or some very clever 3D cutting thing to cut the slice, the bit I don't want. So now I can delete this bit that we saw in the past. We don't want that, we just want the back bit. Then, because I copied the reflector, I can drag it back over into the right place. One thing which is really useful is that because all the objects have a center, I can get it lined up really accurately, because I seem to remember it's 67.76 millimeters it ended up being as the center. So all the different components, if I selected them, I could say, okay, I want X to the right to be 67.76. Now the next exciting job is to make some sort of some finger-like objects that will grip and hold and support the reflector. Obviously you don't just want them at the back, and because I've got that disc at the front which is hiding the flickering lamp, I need to have some way of supporting that. So what I'm going to do, as you can see, I've got a copy of the reflector, and then I've done a duplicate of that and I've enlarged it. And now I'm going to subtract it away to leave some sort of finger thing, and I haven't moved it quite far enough forward, so I'm going to do that now, so that when I subtract it, it leaves the center of the green rectangle floating, so to speak, so I just get the bit I want. Look at that, it's not amazing? So now I can delete the top and the bottom bit, and that will leave me with the shape I want for the support. And then again, I can delete the original rectangle, that one, and then move the new one over to center it up on X as 67.76. I think I need to get out more if I can remember coordinates a few days later. Still, mustn't grumble. So I've painted it brass colour, and now I've realised I need to have enough structure at the top to put a screw, an M3 screw in, so I'm just adding a cube to that. And then to ensure that it will print, because obviously if you suddenly step out like this on a 3D printer into the overhang, there's nothing supporting it, it won't print properly. You can opt and select to have a support structure made, but that's really takes up lots of plastic and loads of time. If I can get away with it, then I will. Now what I've realized is I can do a duplicate, and then look, and then forgot to unpadlock it, and I just increased the Z. So now I've got a perfect curve which the 3D printer will quite happily print from the right hand side, if you see what I mean. I can now delete that green bit, and it leaves me with the area that I need. It's just amazing. And then I'm going to add I think it's 2.5 millimeter a hole in that, so that I can later on tap it. But in the end I just basically imported an M3 thread that it can tap, which is absolutely amazing. So I can just align that and get everything done for this one before I start copying and rotating it. Here we are, copied and rotated. Obviously copied, duplicated over both sides so that I can rotate them around the center, and then I've got 6 of them around the outside now, which I'm going to delete the bits I don't want, having ungrouped them first of all. I just want 3 around it because I think it'll look really nice, and also having a single one at the bottom will sort of somehow line up with the copper fitting at the bottom. I think it's going to look nice, really nice. So I'll get those deleted, and it'll leave me with my desired effect. There we are, ungroup on the right hand side, select that one and delete it, and the little blue bit. So what have we got? We've got that, and I'm very pleased with how it looks. And now I need some way of supporting that brass disc at the front. So I've added 2 cubes which I've stretched and squashed so it looks roughly right, and some discs, some cylinders which I've reduced down, the blue one that you can see. Having those blue bits sticking out helps you to line it all up as well. Now I'm not really happy with that vertical cube rectangle supporting it, the leg that I've made, so I want to add a slightly bowed effect. So I've created a huge ellipse, and I'm going to copy the ellipse over so I've got one both sides. And then what I can do is with the subtract tool, subtract them, and that will leave me with an interesting shape. And if that was a real brass casting, they would have saved material by having it narrowing in the middle. Just brings a little bit more realism to it. And again, I have copied them, duplicated them and rotated them around the centre. I think they look really nice, and now I'm going to paint them brass. There we are. So there'll be the supports for the front part. Very nice. Yeah, thank you. Now I need to add a hole for the alarm set flickering LED indicator. So I'm going to use a brass rod tube at the back behind it to take the wires away, and I've made a little a little cylinder that's 5mm diameter, which is the standard size, well, the size of a standard LED, which I will subtract later, but I'll leave that like that for now. Now another amazing decorative technique, emboss. You select the object you want to emboss something onto. You select whether you want text or an object, some other image, which I'll show you later. This is in Maleficio, the fonts that you can select, the size, move it around to where you want it, and then you click OK. Isn't that amazing? Absolutely incredible. The sky's the limit, like I say. Working in this 3D virtual environment, it's just so amazing. So I've got that now, and it does print really well on 3D. Here's the cup lampshade I made for Erin, the truck driver. It looks a bit odd, but that's just because of the curve. It printed really nicely. You can see there's the flickering lamp in the back. And that was my logo that I turned into a PNG file, image file. I'll show you how to do that later. I thought I'd show you how to add a radius onto an object. So what I'm going to do first of all, it's a bit backwards and forwards, but I've created a cube, a long rectangle. I've also created a cylinder that I want to the right radius, diameter. I've then subtracted it. You can probably see where I'm going with this. And then I'm going to use the slicing tool to slice it into one quadrant. So I've just got a quarter of the shape that I've just created. Then I'm going to line up the quadrants, one of which I've duplicated, where I want on this object, a strange looking thing in the middle. Press subtract, and there you have it. I didn't want completely radiused corners on this, so I had a slightly step back radius. In the end I did change it back again, but that's how you can achieve it. There's the radius part, which I in the end did radius properly. The copper bit at the back, which in effect would, if it was real, allow the gas or whatever that was connected to go up to where the lamp is. I've also added some other little twiddly bits as well, as you can see. One thing to bear in mind is the embossing tool won't necessarily work on really complicated objects because you can't grab it. It gets a bit too confused. So if you do need to do that, what I've found the best way is to just create an object like a cube and then emboss whatever you want onto that. And I'll show you in effect. It'll start off with text, but you can also import an image that needs to be reversed. It needs to be the negative version. Don't know why, but the negative version. So there's a twiddly bit that was a PNG file, image file. I can then arrange where I want that, get the angles and things, and then emboss that on. Like so. And then to get that off there and copy it on, we'll use the slicing tool. Now you can see that once you've got the angle lined up, you can just slide anything backwards and forwards. I'm just going to cut it so it leaves that. And then you can position that where you want. Twiddly bits just make it look so lovely, because the Victorians did love ornate designs. So I'm going to duplicate that, mirror it, and then plant it on the other side. And then finally group it all together. Those rings around the screw holes, I used the insert torus, which is a donut by any other name, shape, and stretched and squashed it, and then sliced the tip off and applied that in the same way, just to get the circular thing. I'm very pleased with that. If you look at the copper connecting bit at the bottom, you'll see in a second that I've added webs in there, so that when it sits flat on a 3D printer, it can print those bits, the overhangs. I've used that with the automaton's heads inside, and it works really well. You don't need then all the extra support structures. Almost there. I got to this stage and I thought it looked too symmetrical, because Victorian engineering, by the very nature of it, mechanical bits and pieces, everything was dictated by the needs of the actual machine itself. It just looked too symmetrical, so I thought to make it a bit asymmetrical by adding some sort of possible pilot light or sensor on the side with a small piece of copper pipe. When I did that, I just think it looks lovely now. Adds a certain je ne sais quoi. Again, they wouldn't have had really symmetrical machines. I also added those 3 rod shapes, oval shapes. Now I'm going to add the M4 and M3 screw threads, which is unbelievable in my petty small mind. The fact that you can actually subtract a thread and get it so good that you can, once it's printed, you can just use a normal machine screw and screw it in. I've used that on the motorized Kraken gauges. So I've rotated them and lined them up with the 3 M3 holes that I want, and just going to move them in and out to make sure they don't burrow right the way through, and then subtract them. It's that simple and incredible. Now I'm going to, with complicated things like this, it sometimes says please wait, because imagine having to subtract a helix, 3 lots of helixes. Oh, it's just amazing. I will zoom in to prove that there is actually a thread cut in there. So that's M3. Because it cuts slightly, it prints slightly larger, I've made the hole 3.2mm diameter. Otherwise it's a little bit tight. I also want an M4 hole there because I've got a brass machined tightening screw thing, so I'll add an M4 hole there. I am very pleased with this design. It's been such a rewarding experience, starting with green blocks and ending up with something like this. Very, very pleased. And now, as I said earlier, because this is all drawn in 3D Builder, all the data necessary can be exported to the 3D printer. And this is very exciting, this design, because it's made up of so many different parts that are going to be printed in different colours. First thing I'm going to do is to lay all the parts flat. It's very important to do this because otherwise it could try and print it floating in the air. So it needs to be flat. Look at that, the settle tool. Isn't that amazing? I love it. So whatever object, each object you need to select and then settle to make sure it's actually flat on Z0, Z is 0. Right, there's all the bits. I'm going to now save each one as an STL file so that I can then import them into the slicer software that produces the G-code for the 3D printer. So here's the Creality slicer software that comes with the 3D printer. I'm going to import the Reflector for the first file, and it will only recognise STL files, hence the fact that I exported it as that from 3D Builder. I'll move it into the middle. This is calculating currently how long it's going to take and how much, 6.5 hours, and how many meters and the weight of the filament that you're going to require. I'll just move it back to the middle. I didn't set it to the middle in 3D Builder, so it's plonked it to one side here. Right, then it will recalculate it. You can have a look around. You can see I'm going to print this from the back, and I've put the web by that extra bit that sticks out, so it should print that, which means I don't need any supporting structure. The only thing I do need is to get it to stick to the base of the bed of the machine when it's printing, because it's just balanced on the bottom. And there are 3 options: none, which I don't want because it'll just fall over and not print properly, something else, and a raft. The raft, it will print a larger disc onto the base, which sticks really well, and then low adhesion to the rest of the print, but sufficiently to make it print properly. Finally, I'm going to save it as a G-code file that I can send to the 3D printer. I hope you found this video interesting. It's slightly different from the normal ones. I've gone into it in this much depth because I just got so excited by the potential of designing things in 3D Builder. I thought I'd share that in the hope that it'll support others. Thanks very much for watching. Next time I'm going to start printing it, which will be very exciting. Thanks again. Oh, and remember, there's information on all my inventions and creations at steamhead.co.uk.